Assalamu alaikum warahmatullah. I am recording this video for SS3 to revise one or two theoretical things around electromagnetic induction. Yes, I know Malama must have done justice to it, and if it happens that you are not in the class, this is just something to help you too as well. So, I want to quickly discuss the theoretical part of electromagnetic induction with you, and it is as follows. I want you to listen. So I have some piece of material that I researched here, and I believe they are very simple language, and it is going to be beneficial to you as well as I explain. So electromagnetic induction. First of all, I want us to understand electro. Let's dissect what this word means. Electromagnetic induction. So, induction has to do with production. To produce something is to induce something, to make something happen. Is that okay? So, if we are producing current or EMF, electromotive force, we are inducing EMF or electric current. So, electromagnetic induction has to do with producing electric current. That's where electro comes in. Producing electric current or EMF or electric current using when there is changes in the magnetic flux linking. So that is from the magnetism that is happening there, we are producing electric current from magnetism. That is the concept. So the concept of electromagnetic induction is how we produce electricity, electric current or EMF, electromotive force from magnetism. So, but you know, magnetism, they have the line or the field of line, right? The magnetic field has magnetic field we have magnetic flux, and magnetic flux are the lines in the magnetic field, right? The lines around the magnetic field. Now, this magnetic flux that is linking the conductor, you know, you want to make a conductor to have electricity. You want to produce an electric current. So to produce an electric current, there will be a conductor will be closer, will move closer to the magnetic field, their magnetic line of force. So what we are now simply saying here is that we say that electromagnetic induction, it is the process by which electric current is being produced, by which electric current or EMF is being produced when there is a change in the magnetic flux linking the conductor and the magnet. So it is just simple. The magnetic flux is the one that is going to be linking the conductor. So within that space where the magnetic flux is linking the conductor, so when there is change, there is going to be production in current. So if there is no change, there is not going to be production of electric current or EMF. So it is the process by which this electric current or EMF is being produced when there is change in the magnetic flux linking the conductor. We say that is electromagnetic induction. That process is what we call electromagnetic induction. Is that okay? Now we have so in a very simple term, in a very layman term, we can simply say that electromagnetic induction is the changing in magnetism that produces electricity. The changing magnetism that produces electricity, because the magnetic flux, when it changes, there's going to be electricity that's going to be produced. The changing magnetic flux to produce electricity. So that's the concept. So there are some a few of history behind this, and the history goes thus. It was started by Michael Faraday. Everybody knows Faraday, and that is why we have Faraday first law, Faraday second law of electromagnetic induction. So what does Faraday? Well, what year did Faraday do his work? I think it was 1931. So 1831, Michael Faraday discovered electromagnetic induction, how to produce electricity from magnets. How to produce electricity from magnets. And what did they discover? He noticed that electric current or EMF is being produced when there is changes in the magnetic flux linking the conductor. Is that okay? So he showed that current is induced when there is a change and not just depends on magnetic field. Say yes, you have to have magnetic field, but what he noticed was that when there is change in the magnetic flux, that is when electric current is being produced, and that's why we say that he was the one that discovered it. He noticed that and discovered that something is happening, that electricity is being produced as there is change in the electric current. I mean, there is change in magnetic flux, not just the fact that we're having magnetic field. No, there must be a change in the magnetic flux before you can have current produced or EMF being induced. So what do we even call this magnetic flux? I believe I must have explained it a bit, but to do justice, let me tell you what magnetic flux is again. So if you have a magnet, you have a bar magnet, you have north south. So the lines of action, or where the impact of the magnet can be felt. So these lines that are directional. So these lines of force. So the lines of force are referred to as the magnetic flux. So the line of force. So when we say that what is the magnetic flux, we say the magnetic flux is the number of the magnetic field lines, around a magnet. So, and it has a particular area. Yes, we should understand that magnetic field is a region of space where the impact of the magnetic flux can be felt. And when we're talking about the region of space, that is what area is all about. In mathematics, when they ask you that what's the area of something, they are trying to ask you what is the region of space that something covers. That's the area. So the region of space that the magnetic field covers. So the magnitude of the numbers of the magnetic magnetic field lines, the magnitude of it is what magnetic flux is. So the magnetic flux is the measure of the number of the magnetic field. Is the measure of the magnetic flux. Magnetic flux is the measure of the number of lines of magnetic field lines. So the measure of number of magnetic field lines. So something like this. It is the measure of the magnetic field lines. I hope we get this. So the measure of magnetic field lines is what the magnetic flux is, and within a given area. So there is a formula for it. So we have this to be equal to a BA cos theta. So, and where this B represents the magnetic field strength, the strength of the magnetic field, this A represents the area that the magnetic field can be felt, and this theta here is the angle between the magnetic field and the normal to the area. The angle between the magnetic field and the normal to the area. So that is that. So what is the unit of this magnetic flux? It is measured in Weber. This magnetic field strength, this one is measured in Tesla. So it's measured in Tesla. That Tesla is represented with capital letter T. So Weber is represented with WB. So we should take note of that. So the This theta here is angle, the angle between the magnetic field, that is B, magnetic field, and the normal to the area, So the angle between the magnetic field and the normal to the area. So that is that about that. And